recording. All right, so we've got 8 of you in here, 7 are in the Nearpod. We're going to get going. If you're not in the Nearpod and you need help, yes, it is. I apologize. We got access to this new AI thing through our Google account. It's called Notebook, and I've never used it, and I tried it, and I like it. I have a 16-year-old child. I also have an 18 and a 20-year-old child. And my 16-year-old is like hates AI and is very against it. And like he saw me making this yesterday, and he was like, like it's all mad at me for using it. But I don't know. It's a big time saver. Okay, so have you guys learned about isotopes in your lessons yet? Are you to that point? I believe if you're on track, you should be. Isotopes are just the same element, but they have a different number of neutrons in the nucleus. So what determines what element it is? What determines the identity of an element? Does anybody remember? Fantastic. Atomic number, number of protons. Those are the same exact thing. So everybody that typed it in is correct. So isotopes are the same element, but they just have a different number of neutrons in the nucleus. So we're going to do some exploring. Oh, this is making me, let's see if it'll log me right in. So try and click on that in the Nearpod and see if it lets you in. And then let me know if it does. Okay, so now it's going to make me share. Hold on. I only shared a tab. I need to share the whole screen, I guess. You want this one? Let's try this. Okay, so it's asking for login credentials. So what I need you guys to do, this is going to be a little cumbersome, is if you go back to a Connexus tab, you all probably have a Connexus tab open somewhere, because so what you're going to have to do is click on your Connexus tab. Here, I'll show you. And you click on the waffle icon, and then you're going to find the icon that says Gizmos, and then you're going to click on Gizmos. Okay. So you have to sign on through the waffle. Oh, it will let you? Okay. I am not real tech savvy, I'm going to be honest. I just go in through the waffle. And so this will open up Gizmos. I'm not sure what it's going to look like from your side. I did add you all to a class in Gizmos. So you should see something like this. So let me know, like raise your hand or do some sort of a reaction once you get logged into Gizmos and you see this. Okay, so you see 4 assignments in the class tab. Okay, because I've been adding stuff that I think I want to use this year. So click on the one that says isotopes. Because my view is a little different than yours. Oh, this took me back home too. Okay, so I'm going to find it. So you're going to go to the one that says isotopes. There are 2 isotopes assignments. Maybe I added it twice. Oh, there are 2. Just click on one of them. They're the same. I guess I added it twice. I like all the feedback because this is all brand new. So I've never done this before. We haven't used these before. We're just giving it a try here. Okay, so is everybody seeing this now? Because you can just watch me do it, but it's way more fun if you do it yourself. Okay. So I'm going to go back to my Nearpod. And if I'm going too fast and you guys are lost, tell me. And the Nearpod's going to show us what to do with this gizmo, basically. And I haven't figured out, there's like worksheets that go with the gizmo. I put the worksheet into a Nearpod. I haven't figured out the best way, but so this is just quick review. What particles make up an atom? We know this. They're right here. Protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Electrons are outside the nucleus. Protons have a positive charge. Electrons have a negative charge. Neutrons have zero charge. Are we all okay with that at this point? I feel like we should be. Okay. And if anyone is stuck and don't know what we're doing, there's a link to the Nearpod. Here, I'll put it in the chat again. So you can join the Nearpod. Or there's a tab in class as well. Okay. So atoms of the same element come in several different versions. Some are stable, others are not. And these are called isotopes. So this is what you're going to do. So I'm thinking what I'm going to do is just maybe leave this up, but you're going to select hydrogen 1 and turn on show isotope notation in the gizmo. Maybe I can do a half screen. Would that be better? If I did this half, and where is the gizmo? Not class. And this one. Why did my gizmos go back? Sorry. Okay, so which particle determines what the element is? We talked about this a little bit already. And I want to hide this. Let's get rid of that. How do I get rid of that? There we go. Okay, so which, and we're going to hide this so we have a little more room. Which particle determines the element? The protons, exactly. Which particle creates a different version of the same element? Or an isotope? Exactly, the neutrons. So over here, it says set protons equals 6 and neutrons equals 6. So we're going to set our protons to 6 and our neutrons to 6. Okay, and you can see over here in this graph, we're going to use this a little bit later. It was moving around and changing colors. And then up here, we get some information. This is carbon 12. This is a stable isotope. Most carbon that is found in nature, in the world, is carbon 12. Okay? So this is a stable isotope. Okay? 98% of the carbon found in the universe is carbon 12. So if we add a neutron, now what is the name of this isotope? Yep, carbon 14 is cool, some people think. So what is the name of this isotope? It says it right up here at the top. This is carbon 13. And it's also stable. But you can see only 1% of carbon is carbon 13, not a whole lot of it. This is one you guys have probably heard about before, is carbon 14. Exactly. Carbon 14 is used in carbon dating because carbon 14 is radioactive. Okay, so it decays over time. The half-life is very, 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 very long, 5,730 years. And we can see it turned green on our graph because green on this graph indicates that it's radioactive. If we take away a neutron, it turns back to stable. We could go a bunch. And carbon 25 does not exist. Okay, so this is just kind of how this gizmo works. Okay. We okay so far? Everybody following along okay? If you have trouble, let me know. So notating these isotopes, you can see this is an isotope of helium. We have a little number 4, a little number 2, and then the symbol for helium. One thing I do want to point out, the chemical symbols, it's very important that you specify the uppercase letters versus lowercase letters, big H, little e, because if you have like a big H, big E, that could be a H atom bonded to an E atom, which there isn't really an E atom. But it's just really important that you notate the upper and lowercase letters. So if you turn in capital H, capital E, that would be wrong. Okay, so just pay attention to that. So this top number, the 4, is the mass number, protons plus neutrons. The bottom number, the 2, is the atomic number of protons. Okay, so top number is mass number, bottom number, number of protons, or atomic number. Okay, so this says turn off isotope notation, set protons to 3, set neutrons to 4, and write this isotope in isotope notation. So you guys can just make a little note of that. Carbon 22. So what would this look like? I wonder if I can draw on this board. I don't think I can. Well, you can double check what you think it should be by clicking show isotope notation, and it will show it. 7,3 lithium. Big L, little I. You might need a periodic table because you wouldn't necessarily know the chemical symbol for lithium. And a good periodic table, I'm going to put it in the chat. This is one that I mean, you can use whichever one you want. Print one if you want. You guys probably don't ever print things. I'm an old lady. I do love to have this paper in front of me. But P table is a good one that I like to use. Has lots of information. Okay. Observe. Set protons to 8. Neutrons to 9. And this is oxygen 17. Okay, so this has a mass number of 17, atomic number of 8. Okay, I feel like this is okay. We're doing fine, right? Yes, hopefully. Okay, eventually you guys will have some work to do. Now is the time. So this is a table. I'm going to actually click to the next slide because you guys are going to fill this in. You can use the Gizmo to help, but you're going to complete the table. So I'll do the first one with you. So we can do this without using the Gizmo. So the first one, I'm going to attempt to write. I'm going to make the crayon skinnier though. So the first one, the mass number is 35. The protons are 17. We can figure out the neutrons because protons plus neutrons equals mass number. So the neutrons are going to be 35 minus 17. I guess I could write that down for you. 35 minus 17, which is, use your math skills, 18. So the number of neutrons is going to be 18. Isotope notation, this is going to be hard to fit in here, but we're going to put the mass number, the number of protons, and then the chemical symbol. And it is chlorine, right? Now I'm having a brain malfunction. But it is, I know this. Because I don't have my periodic table open. And again, it's not CI, it's big C, little L. Okay? Oh, and it gave you the symbol right here. So I'm going to give you guys a couple minutes to fill in the rest of that table. If you have questions, let me know. You can use the Gizmo to help you. Questions on what you're doing? Where do I see a Let me look. Because that is not a common element. What is the protons 95 that I can find it on the periodic table? Oh, yes. Way down at the bottom in the actinide series. Americium, maybe? I'm not sure how you say it. And you'll notice as you're looking at the periodic table, they're in order according to atomic number, which is pretty great. Okay, we're going to hide student names and answers, and then we're going to look and see everybody's working. This is fantastic. Somebody already submitted. They're real fast. And you can also type on that screen. If it's easier for you, you can do little text boxes and move them around where you need to put the text. Looks like 3 of you are not playing the game here in Nearpod today. All right, let's check some of these. That looks good, except we forgot a couple. The symbol for hydrogen, 26, 30, 56, iron, 56. Yeah, I think that says 30. I know it's hard. Perfect. You can't read that at all, but that's okay. Because I'm not grading anything. How are we doing? The rest of us. Oh, good. Somebody went to typing. Excellent. It's a little neater. It's hard to write with the mouse. This person just quit. Or maybe they're not sure how to do it. If you have questions, ask. You will be doing this again, I think on the Unit 3 test. It's in the Nearpod. Did you get into the Nearpod? Yeah, it's in there. So just make sure you are on the Nearpod tab. I don't know if you did it in class or if you did it outside of class with the link I put in the chat, but it's in the Nearpod. So you should have a Nearpod tab open, hopefully. Do you see it? No, just the questions. Does it look like this? This one that I'm running my mouse around? Is anyone else having that trouble? Okay, so you should have 2 tabs open. One for the Gizmo, one for the Nearpod. If you want to get the Nearpod, you can just click in class on your class tab. There should be 3 tabs at the top of class, right under where the address is, I guess. Yeah, we're right around where this stuff was covered. And I actually probably dropped some of your lessons up to when you enrolled, I think. Okay, good. Okay, I'm not explaining it very well. I apologize. All right, but let's go through these. So this has hydrogen 1 and 1. So we know that bottom number tells us the number of protons. And if the mass number and the number of protons are the same, that means there are no neutrons. This is just hydrogen 1. Okay. Next one, the mass number is 56 and the neutrons are 30. So if the mass number is 56 and the neutrons are 30, to find the protons, we have to do 56 minus 30, which is 26. Okay, so I'm going to go ahead and put that into my little gizmo here. 26. And then neutrons, instead of clicking 30 times, I'm just going to type them, is 30. And I like the questions happening in the chat. I'm cool with that. And so this is iron 56. It is stable, and you can see the isotope notation where I'm sharing my screen. 56 on the top, 26 on the bottom, capital F, little e. I saw somebody type a capital E. It's a big F and a little e. Okay. Next one is 3114 silicon. So the protons are 14. The total mass is 31. So if I do math, I think it's 17. Is that right? 17 are the neutrons, and the symbol is big S, little I. So we can put that in here. Protons is 14, neutrons is 17, and we get silicon, radioactive silicon. But silicon nonetheless. And then the last one is AM. It has 95 protons. Neutrons are 148. What's 95 plus 148? Let's get my calculator because 243, 95, 243. Big A, little m. 95, 243. We got to zoom this out to see it on our graph, and that is not even existing. Okay, we're good with that. Protons, neutrons, figuring it out, writing the symbols. Yes, I hope. I do not know where americium, however you say it, was discovered. America, good guess. Okay, so this is kind of off topic. This is not covered in, University of Chicago. Look at you guys. This is not covered in Unit 3, but I think it's kind of cool. So we're just going to look at it real quick. We only have a few more minutes. Radioactive atoms have nuclei that can decay into different elements. For example, radon-222 undergoes radioactive decay and becomes polonium-218. They're also called radioisotopes. And then half-life, time it takes for half of the atoms to decay. Shorter half-lives, more unstable. So let's look at this. We're going to build carbon-12. And so carbon-12 does not have 12 protons. Carbon-12 has 6 protons and 6 neutrons. Okay? Is it stable or radioactive? We are not going into decay chains yet. That's much later. Okay, I don't need that. This is just like a little bonus. Radioactive, because it was in this gizmo and I thought it was kind of cool. But we will do nuclear chemistry eventually. But so carbon-12 is stable. Carbon-13 is stable. We looked at this already. Carbon-14 is radioactive, right? Half-life 5,730 years. It's a very long half-life. We can see on our graph, it's a green dot. means it is radioactive. Okay. So now we're just going to look at a few more. We're going to collect some data here for the first 7 elements. I'm going to go back up a little bit on my graph. So here's hydrogen is stable. We're going to save that point on our graph. Helium, I'm just going to do the stable one. We're going to save that point. We're doing the first 3 elements. Lithium, beryllium, this is my favorite element because guess what? Chemistry sure isn't boron, is it? Yes, I love that joke. Sorry. And I keep clicking on my arrow. And carbon. Oh my God, my graph disappeared. Sorry, I told a joke and clicked something. But basically, when you make this graph, you should see that in these first light elements, small elements, the proton to neutron ratio is typically 1-to-1. Not always. Carbon 14 exists. I do have one radioactive one in here. But the proton to neutron, a lot of them, stable isotopes, have a 1-to-1 proton neutron ratio. Okay. But now we're going to look at all of them and the heavier elements. So we're going to make our graph a lot bigger and look at a lot more of these elements. We have to save a bunch of them before it will show all. I'm going to try to do this quickly. We're going to do like sodium. Let me see. With at least 50 protons. So let's go back here. Let's do 45 protons. I'm just randomly choosing elements. We're going to save them. We have to do 5 or 6 of them. We want one that does exist. Save point. Save point. Eventually, we'll be able to show all, hopefully. Come on. Not yet. Not yet. Okay, I just saw your sodium joke. I love it. Okay, why is this not doing this? Show all. Maybe I need one back down. I'll do 30. I did this yesterday and it worked just fine. Well, you can kind of see it. Sorry, I'm almost done. We're going to give up here in a moment. But basically, what this shows is that as you get more radioactive, the proton to neutron ratio changes. Okay, that's what I was trying to show you. I do not know why it's not letting me do this, but it's not. But that's all that I was going to show you. Lots of different isotopes of different elements. You should be good at knowing what that is now. If you guys want to look at these isotopes, you can create these ones and decide if they're stable or radioactive. But that's it basically. Questions, comments, anything of that nature?